आयुष्यामध्ये मी असल्यावर कोणी कॅप्टन होऊ शकत नाही म्हणून त्यासाठी शूज सॉक्स दोन्ही काढले आणि मेघाने खेळत होतो मी आणि सगळ्यामध्ये एक बी आली तिथे Hello guys, are you ready for this? Cylindrical Chapter. He was several counts in the Untitled Chapter. So I have a source here. So
yeah. Physics का?
नहीं यहाँ होगा बेसिक कंफर्मेशन है तो आपसे बच्चा बोल रहा है
नहीं मैं बहुत पहले आया था तब हाउस सर्किट चालू था एकदम पहले उसके बाद कितने लेक्चर सगळं झालं ना न्यूमरिकल आहे
साइंस में ईवीएस आ रहा है ईवीएस क्या पोजीशन है ईवीएस में साइंस ईवीएस सब्जेक्ट है हमें ईवीएस सब्जेक्ट है तो सब्जेक्ट को पता नहीं है
हां इलेक्ट्रोमैग्नेटिज्म चालू
करना केला तुम लोग तो ध्यान देते कुछ भी
वो राइट हां राइट
मैं नोट्स बनाने का वो कोई भी सर ऐसे नोट्स बनाने की कंप्यूटर क्लास की सकती है वो हम चाहते हैं कंप्यूटर क्लास की वो भी टीचर अच्छा कर लेते मैं नहीं बोल रहा अच्छा ये लोग गए थे
क्या इधर
ये लोग लेशा में बोला इधर से पैसा
Good evening, everybody. Good to see so many of you on rainy day. More to come. Okay. How are you? Everything good?
my grandfather expired.
All right. So where were we in the last class? So everybody is present, except Sohan, Johanna, and Devang. Devang is a physics student. Yeah. It's okay. So where did we stop in the last section? Right hand rule. Which one? Right hand thumb rule. So chapter 1 is over, right? Did we cover nature of we had only done right hand thumb rule, is it?
Yes.
Did I cover the magnetic field lines through a loop, circular loop? No. All right, let us quickly cover that. So first of all, we are discussing magnetic effects of time, right? So everybody knows this, right? Effects of what is it? There is a magnetic field around a current carrying wire. So how do we get it? So let us say if you have a wire like this and the current is going in this direction. How is the magnetic field in that? It is given by right hand thumb rule. So if the current is, okay girls, focus here now. So if the thumb is, if say current is going in the upward direction. So you put the thumb in the direction of current and curl your fingers around the wire. So the wire should be like this. Okay, wrapped like this. So this is how the field is. So suppose this is the plane. Right. And this is a hole made and the wire was passing through the plane. Right. And what will be nature of magnetic field? It will be around concentric circles in the plane. This is what we have discussed. So how do we get it? If you hold the wire in the middle and curl the fingers around it, that is the direction of magnetic field. So how are the fingers turning? Like this. So the arrow will be in this. This is the direction. So what is the Clockwise or anti-clockwise? Anti-clockwise, right? When the current is moving on. Now, at any point, what is the direction of the field? At any point. Now we know the direction. It is anti-clockwise, right? So at this point, what you will do? You draw a tangent at that point. So at this point A, the direction is along the tangent. What is the direction here? You draw the tangent there also. So this is the direction. What about the direction here? Along the tangent, this way. Got it? So at any point, so these are circular concentric circles. All circles have the same center. Where is the center? The center lies on the wire itself. Where is the center? On the wire itself. And where are the field lines forming? In the plane which is perpendicular to the wire. So can you see this? This plane is perpendicular to the wire. Isn't it? So how is the plane? Like this. So wire is perpendicular to the plane. And where are the magnetic field lines? In this, in my palm. It is how? It is like this, in the palm. Okay, got it? Now, how do we know that this is how the field will form? By keeping the magnetic compass. And let's say we keep the magnetic compass here, wherever it is pointing, now we keep it there, then wherever it is pointing. So we are putting a dot and joining those points, then we get a circle. Okay? So this was the first thing, magnetic effect of a current. Then we also covered right hand thumb rule. So in the last class, many of you were absent. So this is right hand thumb rule. So what is right hand thumb rule? Right hand thumb rule is when the thumb is in the direction of current and the fingers are right curled around the wire. So what have we done? The fingers are curled around the wire. Right? Then the magnetic field is in the direction of curled fingers. That's how it is. Okay. This was our right hand thumb. Second, now on the same plane, instead of a straight wire, if we have a coil or a turn or a loop, so we have a loop now. So the wire is like this. It's a circular loop. Right. So how the current will enter? The current will enter like this. It will come out from here and it will come down from here. Okay, everybody understood? How is the loop now? Like this. Okay. So now if you apply, so you can apply right hand thumb rule like this over here and over here like this. So how will be the field line now? The field lines will be, draw the field line. It will be concentric circles. Right. Here also it will be concentric circles. So in this case, what is the direction? Okay, like this. In this case, what is the direction? Again, it is in the same direction. Correct? Meaning, if you see the plane of the paper, the field is entering from the first side. So whenever now what is the nature of the field? The field is entering into the coil. Okay? So then this side must be south pole. Because field is entering from this side. It is a perpendicular surface to the coil. And the other side of the coil must be north pole because now field is emerging from it. Where is the attendance sheet? तो ये तो साइन ही था ना पहले से, तो क्यों दिया ऐसे ही काउंट करने के लिए? Okay. Have you understood? Anybody has a rough paper? Give me a rough paper. ये रफ है, सही है भाई। जिगरा बहुत कम लोगों में होता है। So this is the situation. इसको फांसी आना शुरू हो गई। कौन खास रहा है? जानबूझ के खास रहे हो क्या? नहीं, फांसी आ रही। समझ आ गया? देखो, this is how it is. Okay, so this plane is perpendicular to the loop, right? लेफ्ट साइड से क्या हो रहा है? करंट ऊपर निकल रहा है। यहाँ से मैंने सेल लगाया, इसमें से करंट ऊपर से आके फिर इधर से नीचे जा रहा है। तो अब अगर मैं यहाँ पे राइट हैंड थंब रूल लगाऊं उधर, तो कैसा सर्कल बनेगा? ठीक है, यहाँ पे सब कुछ हो रहा है, ठीक है। ये क्यों हो रहा है मुझे नहीं पता, लेकिन हो रहा है। देखो, ठीक है, क्या हो रहा है? ये जब हम राइट हैंड थंब रूल लगाएंगे तो कैसा हो रहा है? ये बड़ा सा सर्कल है, जितना बड़ा सर्कल होगा तो क्या हो जाएगा? स्ट्रेट लाइन हो जाएगा, ठीक है। अब देखो, नाउ लुक हियर, यहाँ पे क्या हो रहा है? ये साइड से करंट ऊपर जा रहा है और ये साइड से करंट नीचे आ रहा है, ठीक है ना। तो अगर मैं ऐसे करूंगा तो उसका डायरेक्शन क्या हो रहा है? सब यहाँ से अंदर घुस रहा है और यहाँ पे क्या हो रहा है? थंब नीचे, यहाँ से भी अंदर घुस रहा है। यानी हमको क्या मिल रहा है? डायरेक्शन, सारे के सारे डायरेक्शन सेम डायरेक्शन में मिल रहे हैं, ऐसे। मिल रहे हैं ना? ये देखो, ऐसे हो रहा है ना। अगर इधर से करंट बाहर आ रहा है तो यहाँ से लूप अंदर जा रही है, यानी ये फेज जो है तुम्हारा कॉइल का, दिस इज एक्टिंग लाइक अ साउथ पोल ऑफ अ मैग्नेट, क्योंकि मैग्नेटिक फील्ड अंदर जा रही है और ये फेज जो है वहां से बाहर आ रही है, ठीक है। सो दिस इज द स्मॉलेस्ट इलेक्ट्रोमैग्नेट पॉसिबल, वन लूप और अ सर्कुलर कॉइल, ठीक है। सिंगल टर्न का इज द स्मॉलेस्ट इलेक्ट्रोमैग्नेट। ये चीज समझ आ गई, ठीक। और हमने राइट हैंड रूल यूज किया दोनों तरफ एंड वी गॉट द फील्ड पैटर्न। ओके, सो कैसे देखो, तो अभी इसमें वायर में क्या है, क्लॉकवाइज करंट है। ये जो वायर है ना सर्कुलर लूप, कैसा है अभी, whenever the current in the wire is what is the current in the wire, clockwise in this case. So this side is what, south pole, right? ये एरो से इसको अलाइन करो। सो ये हमारा रूल हो गया, ठीक है। क्लॉकवाइज करंट, सबको समझ में आ रहा है मैं क्या बोल रहा हूं, मीन्स साउथ पोल। समझा? तो जब भी कॉइल में करंट क्लॉकवाइज दिखेगा, तुम ऐसे सामने देख रहे हो, तो वो साइड से फील्ड एंटर हो रही है, ठीक है, देन इट इज साउथ पोल। और जब हम दूसरे साइड से देखेंगे, देखो जो तुमको यहां से क्या दिख रहा है, वो मुझे क्या दिख रहा होगा, तुमको क्या दिख रहा है, करंट कैसा दिख रहा है तुमको, क्लॉकवाइज, तो मुझे कैसा दिख रहा है, एंटी क्लॉकवाइज, ठीक है ना। कॉइल वही है, इस साइड से साउथ है, तो ये साइड से क्या हो गया, नॉर्थ। तो हम क्या बोलेंगे, एंटी क्लॉकवाइज करंट विल गिव मी नॉर्थ पोल। तो नॉर्थ पोल को हम कैसे बना देंगे, ऐसा, विल अलाइन द डायरेक्शन एन, ठीक है। सो एंटी क्लॉकवाइज करंट is south pole, sorry, north pole. मतलब when you are looking at the coil, when that current is anti-clockwise, that means you are facing a north pole. That means field is coming out from there. Isn't it? This must be south. This must be north. Okay. सब कुछ समझ आ गया? Where is the current entering from? Left side. That time this will be south. But for me, the current is coming out from right side, so it is anti-clockwise. Is it clear now? Okay. Now see the diagram in your book and try to understand and visualize the situation. So what we have discussed just now is we just covered magnetic field due to current in a loop or circular coil. What is this topic? Magnetic field due to current carrying loop or circular coil. So the question may come, draw the magnetic field pattern for a current carrying loop. You have to draw this diagram. Okay. Then there will be question, explain clock rule. So clock rule is for clockwise current and anti-clockwise current. Okay, what is this? Clock rule. What does it give? It only gives to identify which pole it is when the current is clockwise and when the current is anti-clockwise, when you are facing the coil like this. Okay, is it clear? So hope you are familiar, like from south pole the field enters in the magnet, You know that, right? Whenever you have a bar magnet, you know this, right? North and south. How is the field pattern? Like this. It is a closed loop. In the first lecture I told you, right? So it comes out from the north pole and enters from south pole. So this you have to know. Like everywhere, wherever the south pole, the field enters into it. Wherever there is north pole, the field comes out from it. 9th में पढ़ा है ना? Any questions till here? Next topic is magnetic field due to current carrying. Due to current carrying cylindrical coil. Magnetic field due to current carrying cylindrical coil. So, what is it? That is solenoid. So, what is current carrying cylindrical coil? Solenoid. Okay. So, now what we will do? So, what is a cylindrical coil? देखो अभी तक ये coil कैसा था उसमें एक ही टर्न था ऐसा. So when we say turn or a loop, अब हम क्या कर रहे हैं इसको? We will mount it on some core. अब ये क्या बन गया? What is it? Like a spring, right? So this is called cylindrical coil. So how many turns are there? 1, 2, 3, 4, 5, 6 turns are there. वो ये एक टर्न वैसे ही है जैसे हमने अभी देखा. ठीक है? So now how is the magnetic field pattern in this case? So see, when you have a core, you have to understand on the left side it is going from above the core, right? Then on the right side it is coming from behind the core. This you have to remember. Okay? Right? Can you see this? The wire on the left and right side is different. One side it is turned above the core. This is core on which it is wound. Okay? And on the other side it is from behind the core. Is it clear? Can you see this now? एक आगे से और एक पीछे से. ठीक है? तो उससे क्या फर्क पड़ता है? देखो, उससे ये फर्क पड़ता है. Here current is going upward, let us say. For convenience, we'll take always the current is entering from left side. Then right side में क्या होगा? It is coming down. So if you look at the area of cross section, here it is which current? If it is entering from here, it is anti-clockwise. And if it is coming down, then what kind of current you are getting? Clockwise. ये चीज समझ आ गया? Always in case of a solenoid or cylindrical coil, the end will be, the nature of current at the ends will be opposite. If left is clockwise, then this will be anti-clockwise. It will depend how the wire is wound. If this wire was wound from behind, then this will be clockwise and this will be anti-clockwise. तो समझ आ गया? फ्रंट में वाउंड है कि बिहाइंड में वाउंड है, उससे क्या होता है? टर्निंग चेंज हो जाती है. द सेंस ऑफ रोटेशन चेंजेस. क्लियर? अच्छा, बस. तो इसमें कैसे बनेगा मैग्नेटिक फील्ड? देखो, so how to draw the diagram? First you draw the core. Okay, so this is your rectangular core. Then you wind the wire like this. Let's say I am winding from behind. ऐसे करना है. ये वायर पीछे से लेके टर्न कैसे करना है? ऐसे ऐसे. Okay, enough. Okay. So the last wire should come from above because first wire is behind. Okay. Now how the current is going? This is plus, this is minus. So current will flow like this. So how will it come through the turn? Like this. So when you see it from this side, how is the wire current? It is clockwise, right? And if you see it from this side, how will you see? Anti-clockwise. Okay? So what will be this end then? If this is clockwise, this must be south pole. This must be north pole. Understood? Very easy. So when you draw the diagram, you have to be careful how the wire is wound on the core. So this is your core, right? This is your cylindrical coil. Now tell me, how will be the magnetic field pattern now? It's very easy, just like bar magnet. If this is north pole, then the field must come out. Right? This is how the field pattern will be. And it will enter the south pole. Okay? Likewise from below. Right? So if you know the sequence, then it is very easy to. Everywhere we have got the field pattern by applying right hand thumb rule. Anybody has any questions? Please feel free to ask. So where are the field? It is between the coil. Ring is outside. Okay? Where is the field? It is between. So if this is clockwise, then this is south pole. The field is entering from here and it is coming out from it. Okay? Oh yeah. Okay? So this is how the electromagnets are made. So how to make this kind of permanent magnet? Maybe there is a magnetic field inside it. So keep the substance like steel or soft iron. When you keep the iron there, it will get magnetized. Okay? Pass the current for a very long time and you increase the number of turns. So when you increase the number of turns, each coil is producing magnetic field. So if it is 10, then it will be 10 turns of field produced by one coil. Or increase the strength of the current by adding more cells. You can increase the current or you can increase the term, right? Or put inside some soft iron core. So the magnetic field can be increased by these three methods. How can you increase the magnetic field? By increasing the current magnitude, okay? By increasing the number of turns, or by inserting a magnetic substance such as soft iron or steel. Got it? And that is also a method to produce permanent magnet. When you put steel, then once the current is switched off, that steel remains permanent magnet. But if you put soft iron, then it will lose magnetism the moment current is switched off, because it has low retentivity. It cannot retain its magnetic behavior once the current is switched off in the electromagnet. Got it? So soft iron will act as magnet as long as current is flowing through the solenoid. Whereas in steel, it is a permanent magnet. So when you have a large crane, okay, which has electromagnet to pick up the iron scrap. So you switch on the current, switch on the electromagnet, pick up the scrap, take it and switch off the current, and it will drop it. So you have the magnetic behavior at will. So it acts as a magnet at your command, not all the time. So there you have to use a soft iron. Okay, is it clear? So this is what it is. So this side must be south pole. So when I view from this side, okay, this end, and this will be my north. So by applying these rules, I want to know this is north pole and south pole. So generally the question which will come on this topic is draw the magnetic field pattern for a solenoid or a cylindrical coil. Then you have to draw this diagram. So what is the steps? Start with the core, then the winding, mark the direction of current, and once the direction of current is marked, you can identify which pole it will generate, and then from south enter, from north come out, and complete the loop. Because magnetic field lines are always loop and they will not cut each other. No magnetic field is completing the loop by itself, but it is not crossing. Okay. So see this diagram in the book. So in the book, what they have done is they have shown a perpendicular plane like this. And now there are so many wires. Okay. They have repeated the layer. And if you see it from the front, it will look like this. So I used it on the core, not on this, because it is a hardware. To make that many turns will be difficult. But I can do if you want. You wanted to do it? Or have you understood?
So the current is going upwards. So
From this side.
the direction will be anti-clockwise.
It is clockwise, no? You're not convinced. Okay, I'll show you how. Why it is come here? Come here. Come here. So look at the diagram. Okay? Now hold the core like this. Hold it. So where is the wire now? It is behind. Okay? So how it is? It is behind. So if I now it is behind, right? So now what I will do is I will turn it on it. So how is it? Is this same now? Like this diagram? Now current is entering up. So what is it? Clockwise or anti-clockwise? So this happens initially. This is the same diagram, right? The wire on the left and the wire on the right. You see, one is going behind and the other one is coming from outside. Now the current is entering like this. Now when you see it like this, you will see the current like this. It is going up from behind and coming down from right. It's like this. Up. So how? The wire has to be in between the grip, like this. Then the field is going up. You have to be very careful. The field is going through the coil. Okay? Thumb is like this. So where is the finger? Thumb you keep out. So the finger has to encircle the wire. Then it is going inside. Take it, try. Face the class. Explain that. So this is how this is what it is. You are it, na? So why not of this? This is same, right? As it was. Now it is to always. Yeah. Hold on the left side. No, just see if it is same or everybody get your doubts cleared, huh? Because this is the thing to be understood. Rule is to be applied by right hand. Then only you'll get the correct thing. Kabhi kabhi kya hota?
Current will go upwards like this. No?
Current is going upward. Huh? So where is your fingertip? So wire you have to grip the wire. Wire has to be in between your finger and thumb. So where is the field coming?
This direction.
Yes. So so for a coil, you have to see where you are applying at this point. The direction is up. So where is the finger at that point? Inside. Not outside. Outside is here, but where you are checking? In the circle, na? So in the circle, where is the field? So these are the points. Let's say this point. Its current is here. Okay. Okay, wait. We'll make a bigger circle. छोटे से तुम करते हो. Let's take just. Okay, now how many turns are there? 2 turns. Let's make it 3. Okay. Okay, all right. This side, now how it is? This is how it is, right?
Yes, sir.
So where is it? You take the reference as this point. So at this point, when the current is going up, where is the finger?
Inside.
So what is the confusion? So if this is going up, then this is clockwise, no?
So I was confused. I was doing from the outside and understood it was going anti-clockwise.
No, so let you fix a point here, let us say. If the direction of thumb is up, at that point, where is the field?
Inside.
So concentric circle at that point, right? Whichever is the point, here the current is up. So where is, so there is circling everywhere. So the net field is inside. Okay? Anybody else has doubt? I can guarantee 99% of you will not be able to answer correctly. Those who are saying yes.
Sir, in exam, do they have to draw that?
Yes, that's why I'm asking again and again. You have to not only draw, you have to also identify the pole, which pole it will develop. The one who is trying to understand will struggle. The one who is watching movie will be at ease. Okay? This is concept. Have you understood? Just pass it on. Check. I mean, understand and then pass it on. So this chapter has only this much. So what are the similarities between a current carrying solenoid and bar magnet? Same field pattern like a bar magnet. Solenoid and so all the boys get together, all the girls in two groups, huh? Three, a group of 4 and 3. So फटाफट girls के पास भी भेज. Similarities between solenoid and bar magnet. So first verify that. What are the similarities? Similar then when suspended, we rest in non-stop position. ठीक है? Then third is attracts metallic substances. Such as iron pieces. तो जो सोलेनॉइड में जो मैग्नेटिक लाइन है, ठीक है, और जो बार मैग्नेट का मैग्नेटिक लाइन है, सिमिलर फील्ड है, ठीक है, यू कैन सी दैट बार मैग्नेट का जैसा है वैसे ही सोलेनॉइड का. When you suspend the solenoid, this also rests in north-south direction, just like bar magnet. Then ये भी it attracts metallic substances. तो ये similar points हो गए, ठीक है. What are the dissimilarities? Dissimilarities में क्या है? This is not permanent. It's a temporary line. Dissimilarities. With bar magnet. Temporary electromagnet or temporary magnet. Temporary. कब तक मैग्नेटिक प्रॉपर्टी शो करता है? जब तक करंट चालू है. Till the current is flowing. Current is flowing through solenoid. ठीक है ना? So unlike bar magnet जो हमेशा ही मैग्नेटिक रहेगा, ठीक है. Second, its polarities can be changed. Like ये south है, ये north है ना. If you change the direction of current, तो ये क्या हो जाएगा? North और वो क्या हो जाएगा? South. बार मैग्नेट में polarity change नहीं कर सकते, ठीक है. Polarities can be changed by changing the direction of current. Okay. Now, can we change the magnetic strength of a bar magnet? No. Whatever is its magnetic property, it will remain constant. Here we can increase the magnetic strength by increasing the current magnitude, number of turns, and by inserting core. Yes. Okay. So we can change the third point is magnetic strength can be changed by increasing the magnitude of current right, by increasing the magnitude of current. Second is increasing the number of turns. Okay. Third is inserting soft iron core. जब भी हम मैग्नेटिक सब्सटेंस डालते हैं तो उसका फील्ड सडनली बहुत ज्यादा बढ़ जाता है. Okay. So this itself is electromagnet. This is electromagnet. Okay.
Soft iron, then we will increase.
Yes, that's what it is. Magnetic strength can be changed or increased. लिख दो चलो इसको change माने increased. Increased. Is it clear now? Is it clear? So whatever changes we are doing will increase the magnetic field strength. Increasing the magnetic field strength means more and more line will come out. Very close, crowded. Okay? पहले कम field lines था, अब बहुत बढ़ गई. Okay.
Distance also will increase of magnetic field.
The region where it can exercise magnetic effect will also increase. That's all. That is why, because the field is not strong, so it can attract object at a farther distance. Initially, earlier, it was attracting objects kept nearby, but now it can, because it can suck anything kept far away. किसने बिगाड़ा इसको? किधर से आया ये लास्ट? ठीक है, सीधा कर दो. ये कॉम्प्लीमेंट्री था, इसका अलग से कर सकते हैं. This gift for you. Okay, so rest is not there in the syllabus. You don't have I-shaped magnet, U-shaped. ये भी 9th में आ गया, है ना? It's not in the syllabus. Electromagnet, permanent magnet ये भी नहीं है. So you must have done it in 9th में किया था ना ये सब? 9th में है ना सिलेबस में? नहीं किया तो वो अलग बात है, लेकिन सिलेबस में है ना. ठीक है, ये 10th में भी दिया है, but it is not in the portion for this. Okay. So now we will come to second part, which is force on a current carrying conductor in a magnetic field and its application in DC motor. ठीक है, बहुत इंटरेस्टिंग एप्लीकेशन है, ध्यान से सुनो. Whenever there is a magnetic field, ठीक है, और उसमें हमने क्या कर दिया, एक करंट कैरिंग कंडक्टर प्लेस कर दिया, तो उस कंडक्टर के ऊपर फोर्स लगता है. समझ आया क्या बोला मैंने? नाउ दिस इज यूनिट बी. The current carrying conductor placed in a magnetic field experiences a force. ठीक है, and this is the principle behind working of motors. ये तुम्हारा फैन चल रहा है ना, या मिक्सर चलता है घर में, इसकी वजह से चलता है. तो तुम क्या करते हो, मिक्सर के अंदर क्या होता है, कॉइल होता है, कॉइल. ठीक है, क्या होता है, मोटर. मोटर के अंदर भी रहता है ना. हाँ, तो जब भी तुम करंट ऑन करते हो तो कॉइल के अंदर करंट आया, जैसे ही करंट आया तो कॉइल पे फोर्स लगे, तो उससे वो घूमने लगता है. देखो कैसे. तो दिस इज द प्रिंसिपल बिहाइंड, दिस इज द प्रिंसिपल बिहाइंड वर्किंग ऑफ डीसी मोटर्स. डीसी मतलब डायरेक्ट करंट. जहां पे भी सेल है सब जगह डीसी चल रहा है अपना. ठीक है, अभी एसी डीसी का डिफरेंस वो सब देखेंगे. तो समझो ये तुम्हारा मैग्नेटिक फील्ड का डायरेक्शन है. ठीक है, अगर फील्ड लाइन ऐसे जा रही है मतलब इस तरफ नॉर्थ होगा, तभी तो फील्ड ऐसे जा रही है, और इस तरफ साउथ होना चाहिए, है ना. हमको कब मिलेगा ये, जैसे हमारे पास हॉर्सशू मैग्नेट है ऐसा, है ना. ये नॉर्थ, ये साउथ, यानी इसमें कैसा फील्ड आएगा, ऐसा फील्ड आएगा. ठीक है, तो ये समझो ये हॉर्सशू मैग्नेट है बड़ा सा, और ये बीच का मैग्नेट. These are यूनिफॉर्म फील्ड है. अब हमने इसमें क्या रख दिया है, इसके अंदर हमने कॉइल रख दिया है. कैसे, ऐसे कॉइल रख दिया इसमें. और इसको हमने किस पे कर दिया है, दिस कॉइल इज माउंटेड ऑन सम, लेट्स से देयर इज सम अरेंजमेंट जहां पे कॉइल हमने फिक्स कर दिया है. ये एक्सिस है कॉइल. ठीक है, गॉट इट. So the coil is like this. Let us say this is the coil, a rectangular coil. Okay, this is how the coil is, like this, right? This is the coil. And how is the magnetic field? Let's say two lines are going above it, two below it. ठीक है, तो how is the magnetic field? Like this. Okay, so what is the plane of the coil? This is the plane of the coil. And how is the field? Like this. So the plane of the coil is parallel. Okay, now let's name this coil point this as A, B, C, D. ठीक है, so we are calling this as A, B, C and D. This is the axis of coil on which the coil is mounted. Right? So what is the direction of magnetic field? This. And what is the angle between the length of the coil? So this is the direction of field. Magnetic field. And imagine the current was entering from here, I. So what is the direction of current? Perpendicular to the magnetic field, right? Okay. So where will the force act? It is given by Fleming's left-hand rule, right? Force. ठीक है? ये force का direction. The direction of the force is given by Fleming's left-hand rule. Left-hand rule. Okay. So what is Fleming's left-hand rule? The index finger or the first finger, it is in the direction of field. The middle finger or the central finger is in the direction of current. Then thumb gives the direction in which the force will act. Got it? So on the wire AB, where is the current? So this is your A, this is B, right? Okay? So where is the current? Current is going from A to B. मतलब फील्ड तुम्हारा कैसे ऐसे, करंट कैसे आ रहा है अंदर, बोर्ड के प्लेन के अंदर, ठीक है ना? So you apply Fleming's left-hand rule at this point. तो करंट कैसा है? ऐसा है. हम कहाँ गया? नीचे. Got it? Rudresh, are you understanding? A to B, this is how the direction of current. So current is entering into the plane of the board. This coil is shown like this, but it is like this. B here. So when I apply the Fleming's left-hand rule, middle finger is current direction. तो current कहाँ जा रहा है? अंदर, A से B. तो ये क्या है? Magnetic field. तो thumb कहाँ है? नीचे. ये साइड में thumb कहाँ लग रहा है? नीचे. ठीक है? अब यहाँ से करंट बाहर आ रहा है, ऐसा. फील्ड तो वही डायरेक्शन में है. तो यहाँ पे फोर्स किधर लग रहा है? ऊपर. यहाँ नीचे लग रहा है, यहाँ इक्वल फोर्स ऊपर लग रहा है. तो क्या लगेगा? टॉर्क लगेगा. इक्वल एंड अपोजिट फोर्सेस. ठीक है? घूम गया ना? घूम गया. चलो ये मोटर. ठीक है? तो देखो, तो यहाँ पे फोर्स कहाँ लग रहा है? नीचे की तरफ लग रहा है. F. और यहाँ पे सेम फोर्स कहाँ पे लग रहा है? ऊपर की तरफ. So a couple is acting, right? And the coil will begin to rotate in this direction. ठीक है? अब जैसे ही 180 डिग्री टर्न हुआ, ठीक है? तो हमारा करंट का डायरेक्शन हम कैसे, इसमें करंट कैसे देते हैं? यहाँ पर ना एक ऐसा अरेंजमेंट है, ठीक है? इसको हम क्या बोलते हैं? ये रिंग है जो बीच से कटी हुई है, स्प्लिट रिंग. और यहाँ पे देयर इज सम ब्रशेस जो इसको रब कर रहा है. देयर इज नो रिजिड कांटेक्ट बिटवीन देम. अब ये मैंने पूरा डीसी मोटर बना दिया बिकॉज उसके बगैर तुमको समझेगा नहीं. ठीक है? बट ये एग्जाम में नहीं आएगा, बट फॉर योर अंडरस्टैंडिंग इट इज इम्पोर्टेंट. ठीक है? तो हमेशा करंट कहां से जा रहा है? करंट हमेशा यही डायरेक्शन में जा रहा है. और ये जब CD तुम्हारा इधर आएगा तो डायरेक्शन इसमें चेंज हो जाएगा. अभी C to D है ना. अब जब CD इधर आ जाएगा थोड़ी देर के बाद B और C ऐसा हो जाएगा और यहाँ पे क्या आ जाएगा? B और A. तो अब डायरेक्शन क्या हो गया? जो पहले A to B था बाद में B to A हो जाएगा. तो ये स्प्लिट रिंग की वजह से पॉसिबल होता है. हर 180 डिग्री के बाद क्या होता है? करंट का डायरेक्शन चेंज हो जाता है. तो उससे क्या होता है? तुम्हारा कॉइल हर बार एक ही डायरेक्शन में घूमेगा क्योंकि राइट साइड में फोर्स हमेशा ऊपर लगेगा, लेफ्ट साइड में फोर्स हमेशा नीचे लगेगा. तो ये तभी पॉसिबल है जब कॉइल के अंदर करंट का डायरेक्शन हर 180 डिग्री के बाद चेंज हो. ठीक है? तो फ्लेमिंग लेफ्ट हैंड रूल समझ में आ गया? हाँ? ये लिख लो फटाक से. फ्लेमिंग लेफ्ट हैंड रूल कैसे काम करता है? ऐसे काम करता है। ये क्या है तुम्हारा फर्स्ट फिंगर, क्या देता है मैग्नेटिक फील्ड। ये क्या देता है फर्स्ट फिंगर, ठीक है। और ये क्या है करंट। करंट का डायरेक्शन कौन देता है मिडिल फिंगर, मिडिल और सेंट्रल फिंगर। याद रखना लेफ्ट हैंड ही लेना है, ठीक है। और थंब क्या देता है, ये क्या देता है थंब, फोर्स इज गिवन बाय थंब। ठीक है। एंड फोर्स का जो मैग्नीट्यूड है वो डिपेंड करता है किस पे, आई एल बी के। तो ये लेंथ ऑफ द वायर है और बी क्या है मैग्नेटिक फील्ड। वेक्टर ये भी चलो इसको ऐसे ही लिख, मैग्नेटिक फील्ड क्या तुम्हारा बी, करंट का सिंबल क्या है आई, एफ का सिंबल, फोर्स का सिंबल क्या है एफ। तो फोर्स किसके बराबर है आई एल बी। एल क्या है, ये जो लेंथ है ना यहां से यहां, लेंथ ऑफ द कॉइल ए। तो तुमको फोटो खींचना है तो फोटो खींच लो, घर में जाके बना लेना जो भी है। क्या बोल रहे हो, हाँ अगर तुमने इधर ही करंट का डायरेक्शन चेंज किया, मतलब बैटरी का टर्मिनल उल्टा कर दिया, तो अब कैसा हो जाएगा उल्टा, तो फिर ये क्लॉकवाइज। एनी क्वेश्चन, क्या ये आई एल लेंथ है, ये लेंथ ए बी, ये जो लेंथ है ना ये वाला, ये यहां से यहां। तो ये जो फोर्स है, या तो करंट बढ़ा दो, या कॉइल का लेंथ बढ़ा दो, या मैग्नेटिक फील्ड का स्ट्रेंथ बढ़ा दो, ये फोर्स उतना ज्यादा बढ़ जाएगा। ठीक है, सब लोग एक्सपर्ट। चलो, see you in the next class.
थोड़ा कम है।